Landing Craft Assault (LCA) was a landing craft used extensively in World War II. Its primary purpose was to ferry troops from transport ships to attack enemy-held shores. The craft derived from a prototype designed by John I. Thornycroft Limited, of Woolston, Hampshire, UK. During the war, it was manufactured throughout the United Kingdom in places as various as small boatyards and furniture manufacturers. Typically constructed of hardwood planking and selectively clad with armor plate, this shallow-draft, barge-like boat with a crew of 4 could ferry an infantry platoon of 31 and 5 additional specialist troops to shore at 7 knots, 13 km/h. Men generally entered the boat by walking over a gangplank from the boat deck of a troop transport as the LCA hung from its davits. When loaded, the LCA was lowered into the water. Soldiers exited by the boat's bow ramp. The LCA was the most common British and Commonwealth landing craft of World War II-III. Prior to July 1942, these craft were referred to as Assault Landing Craft, ALC. But Landing Craft Assault, LCA, was used thereafter to conform with the joint US-UK nomenclature system for. The LCA design's sturdy hull, load capacity, low silhouette, shallow draft, little bow wave, and silenced engines were all assets that benefited the occupants. The extent of its light armor, proof against rifle bullets and shell splinters with similar ballistic power, recommended the LCA. Also, soldiers were able to sit, unlike other landing craft which required them to stand. Throughout the war in the Atlantic, the Mediterranean, and the Indian Ocean, the LCA was the most likely sea assault transport of British commandos, United States Army Rangers, and other special forces. Origins. For centuries, the Royal Navy had been landing soldiers on hostile shores, prominent examples being Quebec 1759, Peking 1900, during the Dardanelles Campaign 1915-16, and the Zeebrugge Raid 1918. 5. During the interwar period, however, a combination of recent experience and economic stringency contributed to the delay in producing a modern infantry assault landing craft. The costly failure of the Gallipoli campaign during World War I, coupled with the emerging potential of air power, satisfied many in naval and military circles that the age of amphibious operations had come to a close. 6. Still, throughout the 1920s and 1930s, animated discussion in staff colleges in Britain and the Indian Army Staff College, Quetta surrounded the strategic potential of the Dardanelles campaign compared with the strategic stalemate of the Western Front. The economic austerity of the worldwide economic depression and the government's adoption of the 10-year rule assured that such theoretical talk would not result in the procurement of any equipment. The Munich Agreement of 1938 delayed the inevitable war between Britain and Germany. Munich also led to many changes in imperial general staff policies, among which was the acceptance of a proposal in November from the Inter-Service Training and Development Center, ISTDC, at Fort Cumberland for amphibious assault procedures and for a new type of landing craft. 27. Up to this time, the Landing Craft Committee had produced some motor landing craft, but had not formed procedures for the assault role of these boats. Now there were specifications for what the new boat must be able to do. 7. It must weigh less than 10 long tons, enabling lifting by passenger liner davits. The new craft also had to be built around the load. Apart from crew, it should carry the 31 men of a British Army platoon and 5 assault engineers or signallers, and be so shallow drafted as to be able to land them, wet only up to their knees, in 18 inches of water. 28. The troops had to unload quickly. 8. All of these specifications made the LCA personnel carriers. A separate set of requirements were laid down for a vehicle and supplies carrier, although previously the two roles were combined in the motor landing craft. When the ISTDC approached the Director of Naval Construction, DNC, at the Admiralty to design a craft to these specifications, The DNC staff were urgently engaged in designing new ships to serve more immediate priorities. 8. Germany's coastline was small, and the army would be able to engage the enemy through France. Any urgent need for landing craft was not apparent, and ISTDC were told it would take 7 months to design what was required. 8. The Board of Trade was therefore approached and asked to suggest a maritime architect. Mr. Fleming of Liverpool was proposed, who soon came down to Fort Cumberland, and the design of the first LCA began. Following many visits with new drawings and proposals, a plan was ready by November 1938. 6-9. Approval was sought from the DNC to build a prototype Fleming LCA. A wooden mock-up of the craft had been built in the model shed in Portsmouth Dockyard. Fully equipped troops had practiced embarking and disembarking from it, and the design was altered to meet the practical difficulties discovered. The craft to be put into service was to be built of bermabrite, an aluminium alloy. A meeting with the DNC was convened to discuss the results. The Fleming craft had few friends in the DNC, though their criticisms were not specific. 10. They introduced representatives of 3 shipbuilding firms. The ISTDC were only interested in the Fleming design submitted already, and in trying the craft at a landing on the east coast of England in a matter of months. The DNC accepted this, but asked ISTDC to give their specifications to the firms present so that they could also submit designs. 2 of the firms were unable to tender. The third, Messrs. Thornycroft, had a proposal on the drawing board in 48 hours in ISTDC, and the DNC agreed that construction of a prototype should be paid for. 11. The craft might be constructed for experimental purposes on the understanding that the DNC held no responsibility. J.S. White of Cowes built a prototype to the Fleming design. 2. 8 weeks later, the craft was doing trials on the Clyde. The craft behaved admirably, though it tended to bury its nose in the sea at full throttle. 12. Noise from the 2 120 HP Chrysler engines was excessive, being amplified by the metal hull. Also, there remained the difficulty of applying armor plate to the hull. The sides were not flat, but rounded, a complicated shape for which to roll an armored skin. The bermabrite alloy used also presented chemical and physical obstacles for the application of hardened steel plates. 9. The Thornycroft design was being built at the same time with a hull of mahogany, the internal arrangements for the troops, and exit being generally similar to the mock-up that had been built in Portsmouth Dockyard. The power plant of 2 65 HP Ford V8 engines would be much quieter. The Fleming won competitive trials at Langstone Harbor, compared to the Thornycroft. The Fleming was superior in many areas. Troops disembarked in a quarter of the time. The silhouette and bow wave were smaller, qualities typically beneficial for surprise landings. However, the Fleming remained noisy. During trials on a misty morning, the noisy approaching craft frightened civilians along the shore. Tactical surprise was impossible. 2. Afterwards, Thornycroft produced a prototype to a revised design based on a double-diagonal mahogany hull. The silhouette and bow wave were small, and the twin engines could be made silent beyond 25 yards. Armor could replace the outer mahogany planking. Beaching qualities were satisfactory, something retained by the LCA. There was a lowerable ramp, but disembarkation speed remained unsatisfactory due to the narrowness. The revised Thornycroft became the basis for the LCA. DNC and Thornycroft collaborated to develop the design further, leading to a third prototype, ALC No. 2. Design: Royal Navy beach commandos aboard a landing craft assault of the 529th Flotilla, Royal Navy. All landing craft designs and landing ship designs for ships intended to beach must find a compromise between 2 divergent priorities. The qualities that make a good sea boat are opposite those that make a craft suitable for beaching. 13. The LCA keel was produced from Canadian rock elm, which was treated with steam to make it pliable, and then shaped using a keel block and wedges. 1424 mahogany transverse frame pieces were joined to the keel, providing the overall structure. 15. The craft had a hull built of double-diagonal mahogany planking. The sides were plated with 10 lb. DIHT armor, a heat-treated steel based on D1 steel. 16. In this case, Hadfield's Resisto a quarter. 17. Steps were taken to ensure that the boat would not sink when swamped. In the bow section between the armored doors and the ramp, each bulkhead was packed with 30 cubic feet, 850 L of anazote, a type of vulcanized foam rubber, buoyant material. The same anazote packing was placed along both hull sides for the length of the well, and 42.5 cubic feet, 1.2 m3, filled the aft compartment. 1718. The LCA had a long central well section fitted with 3 benches, one center, one each port and starboard, for seating troops. The side benches were covered by the top deck. The well was divided from the bow by a bulkhead fitted with 2 vertically hinged doors. This pair of forward-opening armor plate doors led to the ramp, which was lowered and raised by a simple arrangement of pulleys and wire. 2 rollers on the leading outboard edge providing some freedom of movement for the ramp when it was grounded. Over this ramp, troops could come ashore in 2 to 3 minutes, or less if the soldiers and crews were well trained. Immediately behind the bulkhead were the steering shelter on the starboard and the Lewis gun shelter on the port. NB 119. The steering shelter was fitted with a telegraph and voice pipe for communication with the stoker, a feather spray control lever, and a fold-up seat. The shelter was protected on all 4 sides by non-magnetic bulletproof plate surmounted by a hinged double-door roof. 20. Most LCAs were fitted with a compass. A newly completed LCA assault landing craft, ready for launching, 1942. Drive was by 2 shafts from the pair of Ford V8 engines to 2 19-inch X14-inch 2-bladed propellers. Fuel capacity was 64 imperial gallons, 290 L. The craft were steered by twin rudders with steering wires that ran from the coxswain's shelter aft through the well and engine compartment, and the last 3-foot unarmored buoyancy section in the stern. The LCA propulsion system was designed to be quiet. At low speeds, the engines could not be heard at 25 yards. 20. The LCA handled well enough in moderate seas when waves were 3 to 5 ft, 0.91 to 1.52 m, but could make no speed against rough weather, demonstrated in the number of LCA-hulled support craft that foundered in 6 ft, 1.8 m, waves while on tow to Normandy, specifically LCA, HR. 21. The power plant, while quiet, has been criticized for being underpowered. Nevertheless, the bow lines and small ramp made the LCA a reasonably good sea boat. Variants. From the start, the Inter-Service Training and Development Center intended to use armed versions of the LCA to provide close support to the troop-carrying types. These variants were armed with heavy machine guns and smoke-firing mortars. 22. The 2 prototype LCA from 1938 were converted for this purpose, and other similar conversions became the MKL LCS, M. 23. The MK1 had a centrally located armored steering shelter just 4 of the engine compartment, and was armed with 2.50-inch machine guns, 2.303 Lewis guns, and 1 4-inch mortar or 20 gun. The crew of 11 included 1 officer, 3 ratings to sail, and 7 gun crew. The Mk2 was similarly armed on a standard LCA hull, except the 2 machine guns were in a twin turret rather than single mounts. 24. These craft were not expected to beach, and later in production boats were given a proper bow, making them more seaworthy. Thus the LCS M3 was produced and stayed in production for the rest of the war. 24. The LCS M3 used Scripps Marine conversions of the Ford V8 engine and had 98 gal. Fuel tanks. 19. The power-operated turret was armed with twin .50-inch Vickers machine guns. 19. The LCA HR Hedgerow was another support weapon variant. The troop well was filled by a Hedgehog spigot mortar weapon. The additional weight of this weapon, and the force it placed on the craft when fired required strengthening of the well floor. 25. This was the same hedgehog used in anti-submarine warfare, with the addition of impact fuse extensions in the projectile nose to detonate the warheads above ground. It fired 24 bombs arranged in 4 rows of 6. Each bomb containing about 30 lb, 14 kg, of explosive. 24. When fired successfully, the bomb pattern was a 100-yard circle about 250 yards forward. The bombs would clear paths through mines and wire on the beach. 25-26. Using this principle of countermining, the explosions from mortar rounds setting off the mines both above and below the water's edge proved very successful. 24. They were used at Salerno 27 and Normandy. Later in the war, the U.S. built a similar craft, the WWII, based on the LCM. 28. One experiment was mounting a flying hose on an LCA as a mine-clearing line charge device for clearing mines and obstacles on beaches. The LCA was fitted with a coil of hose attached to a rocket. The rocket would carry the hose onto the beach. The crew would pump nitroglycerine into the hose, and then attach an explosive charge to the near end and throw it overboard. 29. Fortunately, this system was never used operationally. The same concept was employed by the 79th Armored Division, called Congers, using universal carriers. The nitroglycerin supply for the unit using them accidentally ignited, causing great damage and loss of life. 30-31. While not perhaps a variant, a field modification was developed by U.S. Rangers with assistance from LCA crews and commandos for the famous Point du Hoc assault of 6 June 1944. 32. Each of the 10 LCAs of flotillas 510 and 522, which carried the 2nd Ranger Battalion to Point du Hoc, was fitted with 3 pairs of rocket tubes. Firing 16 grapnels, 32-33. These pulled up by pairs, 3/4 plain ropes, toggle ropes and rope ladders. 32. The ropes and ladders were stowed in 3 large tackle boxes mounted down either side of the LCA decks, and the rocket tubes were positioned down either side behind the corresponding boxes. 34-35. In addition, each craft carried a pair of small hand projector-type rockets, which could be easily carried ashore and fired small 100 FT ropes. These could carry to full extension provided the line was dry and used in moderate weather conditions. Each craft also carried tubular steel extension ladders made up of light, 4-foot sections suitable for quick assembly. 32. These modified craft had the central bench in the well removed. At least some of the LCAs also had smoke floats on the stern, and the armament in the gunner's shelter was a Lewis gun, but a variety of Brens and other light weapons were also carried. Additional support craft variants included the LCA OC, which was fitted to clear foreshore obstructions. 36. Neither the LCA FT fitted with a flamethrower, nor the LCA CDL appears to have been used in action. The latter was a conversion by the parent firm of Thornycroft to carry an armored searchlight canal defense light, originally developed for use in tanks and intended to blind the enemy or create artificial moonlight in a night attack. Though plans exist of a prototype conversion, it is not clear whether it was ever completed. 36. There was an LCA bakery variant to provide fresh bread. 24. Production and development history. With few exceptions, the hull, ramp, and power plan of the LCA remained the same throughout the war. Early on, the coxswain's position was moved from aft to forward on the starboard side. 37 other particulars could vary greatly. Some LCAs having direction-finding antenna loops, others Danforth anchors on vertical racks forward. The hatch layout on the stern deck varied, as did the placement and type of mooring bits, chocks, cleats, fairleads, and fuel caps. Photographic evidence shows all these variations, and also differences in the placement of the lifelines that were looped along either hull side for men in the water. The Admiralty ordered 18 LCAs from Messrs. Thornycroft in April 1939. 22. These early boats weighed more than 9 tons and had flush-decked hulls, an armored bulkhead forward that wrapped around the steering compartment on the starboard side. The steering compartment's armor plate stood about 2 feet proud of the deck line. 2238 in September, 8 more were ordered. Ford V8 Marine conversions by Thornycroft powered the early groups of LCAs. These water-cooled petrol engines developing 65 HP each when driving the 19X14 two-bladed propellers through a 40-120 gear reduction. The twin propulsion units gave a speed of 10.5 knots at 2,800 revolutions per minute, with a load of 8,300 lb, 3,800 kg. In the boat, 36 later craft used propellers with 3 blades. Royal Navy landing craft LCA 1377 carries American troops to a ship in a British port during preparations for the Normandy invasion, circa May-June 1944. The Admiralty placed orders for 30 LCAs in March 1940. By this time, Thornycroft were subcontracting with South Coast yacht builders to fill the Admiralty's many small boat orders, as Thornycroft yards were overtaxed building war emergency convoy escorts and the like. Some LCAs, numbers 24, 29, and 51, were fitted with Parsons conversions of the Ford V8, driving propellers similar to the standard type, but on a 2-1 gear reduction. These LCAs did 12 knots, 22 km/h at 3,300 revolutions. The standard engine fitted in almost all other craft was the Scripps conversion of the Ford V8. Official trial results for craft built in 1941 with this engine show a consistent performance with an unladen speed of 11 knots, 20 km/h, at 2,800 revolutions. 36. June saw 64 more LCA orders, and then between late September and March 1941, another 104. These early craft did not yet have the later standard portside armored Lewis gun position, but nevertheless had framed canvas hold covers, scaling ladders mounted on the decks amidships, and various other refinements dropped when mass production got into full swing. 1939. The finish and performance of these early LCAs were quite fine, which might be expected as these boats were built in established Thornycroft selected yards, but in circumstances of nightly blackouts, air raids, wartime restrictions, and shortages, the LCA building program was a remarkable achievement. 36. About April 1941, the Admiralty decided not to place orders exclusively through Thornycroft and leaving them to subcontract. Rather, the Admiralty placed orders directly with cabinet makers, carpenters, and yacht builders in all parts of Britain. After February 1942, LCAs began being manufactured with deck armor in addition to their vertical armor 40. In the 42 months prior to the end of 1944, Britain was able to produce an additional 1,694. Certain details were modified as production ran, but the basic LCA design remained unchanged for the length of the war. By the time production was in full tilt in preparation for Operation Overlord, production rose to 60 LCAs a month. 37. Sources differ regarding the speed and endurance of the LCA. By 1945, the all-up loaded weight of an LCA had risen to 13.5 tons, due to the addition of further armor and the weight of weaponry an infantry platoon expected to carry into battle. 38. As with all wooden vessels after prolonged immersion, weight increased in the LCA and performance consequently fell. 38. The equipment had evolved and so had the personnel. The time of needing a few craft for raiding was past, and the time for invasion, for scores of flotillas, dawned. Another obstacle to getting the best performance out of the LCA was the early war tendency to return ratings to their various barracks who had landing craft and small marine engine training. Unfortunately, The Navy appointed these ratings to duties without regard to the importance of their amphibious skills. 42. In June 1941, this pattern was changed with the establishment of the Combined Operations Naval Base HMS Quebec at Inverary. Combined Operations was then able to keep trained landing craft crew until boats became available. 43. Crew and flotilla structure. Early in the war, the arrangements for manning LCAs and structure of LCA units was governed by the expediency of the moment. Nevertheless, by mid-war permanent crews and larger formation plans could be kept. Manning the LCA. In Royal Navy service, LCAs were normally crewed by hostilities-only ratings. Personnel of the Royal Naval Patrol Service and officers and ratings of the Royal Navy Volunteer Reserve RNVR. 1343, approximately 43,500 hostilities, only, and 5,500 RNVR officers and ratings crewed the various landing craft types in 1944. 44. Of these, the Royal Canadian Navy provided 60 officers and 300 ratings, on the condition that they be formed into specifically Canadian companies. 45. In July 1943, Royal Marines from the Mobile Naval Bases Defense Organization and other shore units were drafted into the pool to crew the expanding numbers of landing craft being gathered in England for the Normandy invasion. 46. By 1944, 500 Royal Marine officers and 12,500 Marines had become landing craft crew. 44. By 1945, personnel priorities had changed once more. Marines of landing craft flotillas were formed into 2 infantry brigades to address the manpower shortage in ending the war in Germany. 46. In Royal Indian Navy, RIN service, crewing LCAs followed somewhat similar lines. By mid-1941, members of the RIN Reserve and RIN Volunteer Reserve were being trained to operate LCA. 47. In 1942, the RIN began receiving 4 battalions of Indian Army troops to provide crews for landing craft. 700 soldiers of the 9-1 Punjab Regiment volunteered for such a transfer in February 1943. The 1513 Frontier Force Rifles Regiment voted similarly. These battalions were transferred despite the fact that few of the men had ever seen the sea. Citation needed. Their training suffered severely from lack of landing craft, spares, and trained instructors. 48. From around mid-1943, there was also a Burma Royal Naval Volunteer Reserve in existence, working closely among LCA and LCS crews. By 1945, the BRNVR seems to have been formed into the 59th Motor Launch Flotilla. In all likelihood, it had been put together at least partly from those with maritime experience escaping from the 1942 Japanese onslaught in Burma. 49. A junior naval or Royal Marine officer commanded 3 LCAs and was carried aboard one of the craft. 50. The officer relayed signals and orders to the other 2 craft in the group by signal flags in the earlier part of the war. But by 1944, many of the boats had been fitted with 2-way radios. On the wave leader's boat, the sternsheetsman was normally employed as the signalman, but flags, Aldi's lamps, and loudhailers were sometimes more reliable than 1940s radio equipment. 51. The communications equipment of the troops being ferried could sometimes prove helpful. LCA crew. The LCA's crew of 4 ratings included a sternsheetsman, whose action station was at the stern to assist in lowering and raising the boat at the davits of the landing ship infantry, LSI, a bowman gunner, whose action station was at the front of the boat to open and close the armored doors, raise and lower the ramp, and operate the 1 or 2 Lewis guns in the armored gun shelter opposite the steering position, a stoker mechanic responsible for the engine compartment, and a coxswain who sat in the armored steering shelter forward on the starboard side. 3850-253, though in control of the rudders, the coxswain did not have direct control of the engines and gave instructions to the stoker through voice pipe and telegraph. The craft relayed signals and orders to the other two craft in the group by signal flags in the earlier part of the war, but by 1944, many of the boats had been fitted with two-way radios. 51. The sternsheetsman and bowman were to be available to take over from the coxswain or stoker should they be killed or injured. On longer journeys, they might relieve them to rest. They also manned any additional machine guns and operated the kedge anchor if it was required. In minefields and among anti-invasion obstacles and rock, seamen would sit on the bow or stern or move about the sides of his boat piloting or preventing it from hitting the obstacles. 53. Flotilla size. Normally, a flotilla comprised 12 boats at full complement, though this number was not rigid. The flotilla's size could alter to fit operational requirements or the hoisting capacity of a particular LSI. 54. An infantry company would be carried in 6 LCAs. A flotilla was normally assigned to an LSI. These varied in capacity with smaller ones, such as the 3,975 plus ton HMCS Prince David able to hoist 6 LCAs, and larger ones, such as the nearly 16,000-ton HMS Glengel with room for 13 LCAs. 50. From ship to shore. Throughout World War II, LCAs traveled under their own power, towed by larger craft or on the davits of LSIs or landing ship, tank LSDs. An LCA leaving the LSI HMS Roxanne for the island of Nankiray, on the Nicobar Islands, October 1945. Other LCAs are suspended on davits waiting to be loaded before being lowered. In larger operations such as Jubilee, Torch, Husky, and Overlord, LCAs were carried to invasion areas by landing ship infantry, LSI. The location chosen for the LSI to stop and lower the LCA was a designated point inside the transport area when the LSI was operating with a U.S. Navy task force, or the lowering position when with a Royal Navy task force. The transport area or lowering position was approximately 11 miles offshore. 11 miles was amphibious doctrine for the USN by mid-war, while the RN tended to accept the risks associated with drawing nearer shore. Normally, landing ships were fitted with heavy-duty power-operated davits. 53 early landing ships were fitted with Welland-McLachlan davits, these being generally in use in the Merchant Navy for standard 99-man lifeboats. 8. As the weight of LCAs increased through the war, eventually approaching 14 tons, heavier davits were required. Later LSIs and those being refitted were provisioned with luffing davits of a crossbeam type. 55. The davits themselves provided a demarcation between the responsibilities of the LSI crew, either Royal Navy or Merchant Navy, and the members of the LCA flotilla. The LCAs were swung down to the level of the loading decks, and the crews climbed aboard. At this time, the troops were assembled by platoons ready to cross gangways. When the coxswain gave the platoon commander the word, he took his men over and into the stern of the LCA, and they filed forward. The platoon divided into 3 lines, one for each section of the platoon, the outboard 2 sections sitting under the protection of the troop well's armored decks, the center section crouched on the low seating bench down the middle. Despite the wires holding the craft to a fender, the LCA rolled with the motion of the ship. The coxswain would then call "boat manned" to the telephone operator at the loading station, who in turn reported to the LC control room. The coxswain would then warn the troops to mind the pulleys at the ends of falls fore and aft, which could wave freely about when the craft had been set in the water. The task of hooking on and casting off from the ship required skill and seamanship from the coxswain, bowman, and sternsheetsman. The snatch blocks used were heavy steel and difficult to handle. 53 The bowman and sternsheetsman stood by his respective block as the craft was lowered into the water. At a time when there was sufficient slack in the falls, both had to cast off at the same instant, and the blocks had to be released while there was slack in the falls. If the boat was not freed at both ends at once, the rise and fall of the sea could cause the boat to tip, swamp, and perhaps capsize with loss of life. 53. Casting off was done in all sorts of sea conditions, and the sea might be rising and falling a meter or more. 6. Swells were not uncommon on D-Day. A combination of skill and luck could redeem a failure to cast off. Nevertheless, on D-Day, an LCA of Royal Marine 535 Flotilla, LSI Glencairn, released all but its after falls, which were jammed, and the craft tilted alarmingly to 45 degrees. The coxswain kept his head, calming the passengers, while seamen worked to free the falls. 56. Once free, the coxswain needed to get the LCA away to prevent colliding with the towering side of the LSI as it rose and fell with the swells. 53-56.